All right, welcome, ladies and gentlemen, to week number 59. My name is Mr. McLogan, and I am here to answer your questions and also to let you know a little bit about some of my tips for you to get better at math this year. And I just realized I wrote the Get Better at Math for the title of my live stream. But welcome. For all of you tonight, thank you so much for joining me on this live stream. And I'm very excited to talk to you about some of the tips that I think you can take away from this live stream as far as getting better at math and really kind of applying them to your own kind of circumstance and as well as like your own class, you know, whatever class you're taking, no matter, even if it's in a math class. A lot of the content that I wanted to talk to you about tonight, I think can benefit you no matter if you're in a math class or a tough math class or a very introductory math class. And then also I am here to answer your questions. And I want to say thank you to all of my YouTube members for supporting my live streams, as well as those of you that are submitting your questions. You can go ahead and find the link in the description of this live stream to go ahead and submit your questions each and every week for me to go ahead and answer, as well as my link to the Discord server where you can also submit your questions as well as get it answered by other students just like you. So I see you, Mercy and Cassie and Killer and Big Smoke and Creel and Federal and Neptune and Big Blue Line God. Thank you so much. And Addie, thank you so much for joining in. Good to see you guys on the live stream tonight. So yeah, some of the things that we kind of think about when we're, thinking about like improving math or like our skills in math, I think a lot of students kind of like overthink it and, kind of make it maybe a bigger deal than it has to be. And, kind of think that I think one of the big obstacles we have is a lot of students feel like they either got it or they don't got it. And if they don't got it, then they're never going to achieve it. They're never going to be good at math if they don't feel they're good at math from the start. So one of the things I want to talk about tonight is, how can we kind of overcome that? And, there's kind of like three things that I was thinking about that, when I first came up with this topic, I'm like, how is something I can like digest this or, create some topics that something's very easy digestible for students to really take away. And one of the first things I thought about and that I feel is very applicable to all students in any class or really in any skill that you want to get better at is to practice. And, for math class, a lot of times we're doing math problems, we're getting homework. But, I think one of the number one skills, it's not a very great tip to be like, oh, this is this great idea. But guess what? It really is the truth. Getting in some practice and practicing and making sure you're doing the problems correctly. So, the number one skill really getting good at math is, really putting in that practice. It's like any other skill. It doesn't matter if you're doing a sport, that repeated repetition and doing that repeated repetition correctly is probably one of the number one things that I think is going to help you get better at math. And I think what a lot of students will do is they'll, maybe watch their teacher do a problem correctly. They're like, okay, I understand that. Or maybe they'll do a problem on their homework. They're like, okay, I know how to do that. But it really comes into like doing the problem repeatedly and keep on working through different examples, maybe even some examples that are a little bit easier, a little bit harder, but keep on practicing over and over. Multiple examples. And it doesn't have to be like, 20 examples in one night, like this kind of ridiculous. But I think doing repeated examples, even through an extended period of time, is going to be something that's going to be very helpful. So I definitely think that students, when they're trying to improve upon their math skill, doing the math practice is probably number one tip that I'd recommend for you guys. Can you jump up with it? Yes. So I'll definitely get into my equations, some of your examples for you guys as well. But so let's go and take a look at the next example that I'd say is going to be very helpful for you guys in improving your math skills. So getting the practice done, number one. Number two, reflecting on your learning. And when I'm talking about reflecting on your learning, I'm talking about two different really kind of points of this. One is reflecting on the learning like kind of process. Hey, how is this, whatever I'm learning, whatever is being taught to me, how does this connect to what is I already know or what has already been taught in my class? I think that's a very like important kind of concept to understand, and kind of like make those kind of connections, just kind of like step away and really think about like, what is it like that's actually being taught to me? How can I relate this to something that's very basic? Because I think that's really the essential thing with math is, when students can make those connections that of what they already kind of know and apply that to what they're trying to be taught with the math or whatever math concept, that really helps things get defined for them and really kind of makes those connections and really, solidifies their understanding. The other thing that I'd really recommend as far as the reflection is like when you get something wrong, when you go through a test or a quiz or even on your homework and you realize that you got the problem wrong, like, why did you get it wrong? Like, make sure you understand where your mistakes were made, because I think a lot of students overlook this. They look at, math as, oh, I got that wrong and let's just go and move on. But it's like, no, like look back at that quiz and like try to put yourself back into that time frame. Why did you get that wrong? Like, what was going on? What were you thinking? What was your confusion? And I think really when you can kind of like self-reflect on your kind of mind process of where you were when you were taking that quiz or when you got that problem wrong, I think it's going to help you better improve when you're going to see that problem again. Because if you are like majority of students, when these problems, first come up to you, you kind of recognize they're going to come again. And you're going to see these problems over and over. They're going to be reapplied. And you're going to want to make sure that you improve upon those mistakes that you previously made. So, not only reflect on like the learning journey of, what it is you're learning and why you're learning and how it's connected to what you've learned, but also reflect on the learning process, when you're making those mistakes and as well as like your misconceptions and how those impact your learning. And then last but not least, number 3 is this is kind of an interesting one. One that actually I would probably say was not been a tip for the longest time for me, but would be to challenge yourself. And I think it's really important for students to not just be like content with the status quo of like, oh, whatever assignment my, professor, my teacher has given me, like, oh, I'm just going to do my homework, which I think for the longest time, I just felt like, oh, as long as my teacher told me to do these problems, like that's what I'm going to do. But if you really want to get like good at math and you really want to excel in your class, go above and beyond. Like look for those problems that are going to challenge you, to make you think a little bit harder. And hopefully maybe have a class or a book, a textbook that maybe has some of those problems or that's going to be pushing you. But if not, like look out for those opportunities, because I think when you really kind of push yourself into that, into those type of questions, into that kind of learning, that's really going to broaden your horizon. That's really going to make you, that's going to challenge you to think, to step outside of the box, to really do those critical thinking skills. And, over time and time again, I see that, when students are challenged and when you're put yourself in those situations and you're able to step up and really work through those problems that nobody really wants to do, you really get to see the benefits of like, hey, I put my time, my effort, my thought into these problems and like I was able to overcome it. Because I think for a lot of students, they feel satisfied with like, oh, I was able to do these problems, like I'm done. And it's like a stepping stone, like, oh, I'm just done, like moving on. And yes, if math is just a stepping stone for you, then that's going to be fine. But if you're really looking to getting the most out of your math class or, really understanding everything you need to understand, you got to challenge yourself. You got to push the limits of what you understand and as well as what's been provided to you to really get the most out of that class. So to kind of reframe, for those of you that have kind of joined in a little bit later into the stream, the 3 tips that I'd like to share with you as far as getting better at math would be to 1, practice, and make sure you're practicing doing right. Number 2, reflect on the learning process, reflect on what you are learning. And number 3, challenge yourself. Now, all of these 3 things, I actually want to help you guys out get a little better with this, or maybe kind of like utilize these 3 tips. So next week, I'll let you guys know a little bit more as far as what's going on, but I do have a challenge that I'm going to be doing for next week. So I want to let you guys know on the live stream a little bit more about this since you guys are with me. And so next week, I will be releasing the details for the challenge that I think is going to kind of hit on a lot of these. I will provide you with some practice problems to be 31 practice problems to be exact. I'll also give you the answers as well as go through my process of thinking through the problems as well as working through the problems, which will help you with reflect. And then hopefully some of the problems might be a little challenged. Some of them might be easy. Some of them might be hard. So we'll hopefully kind of hit on all 3 of those elements. But that's one thing I wanted to kind of let you guys know about, that I'll be coming out with more details in next week. So, all right. Otherwise, if you are interested in that challenge, though, as far as doing a math problem, roughly 31 of these math problems a day, then let me know down in the chat below, and I will give you guys more details coming up next week. So let me know, though, if you guys are looking for this. Yes, I know I look like Johnny Sins. Thank you, Yarkos. But if you guys are interested in joining me for the challenge, then let me know. Because as of right now, I have a challenge ready for Algebra 2 and Pre-Calculus. But if you maybe have another class you're looking for a challenge, then go ahead and type it in the chat, and we see what I might be able to come up for you guys coming up. All right. So Austin, someone block Yarkos. He's not Yarkos. Yeah, Yarkos. I already know I look like Johnny Sins. I mean, you guys keep on letting me know about this. Nope, that didn't work. There we go. All right. I missed the previous 58 weeks of live streams. Yeah, Lee, you definitely did, but no worries. I will still plan on going live. And again, thank you so much, guys, for joining in. Just a little recap. Each and every week, I go live on Sunday night at 9 p.m. Eastern Standard Time. And the questions that I am about to go over now have been pre-submitted to me using my Google form. If you are interested in submitting a form or submitting a question onto my form, then go ahead and take a look at the description in this live stream, and you can go ahead and submit a question yourself, and I'll do my best to be able to answer them each and every week. But obviously, I'm not going to be able to get to every single question, ladies and gentlemen. So I always advise students to go ahead and take a look at the Discord server, which is completely free and run and by students just like yourself that are happy and eager to help you with your questions. But I always recommend, if you're going to ask a question, then please make sure that you also are helping other students with their questions, because I feel like the only way that community is going to grow on Discord is when students are not only submitting questions to be answered, but also helping each other with their questions. So go ahead and check out the Discord link in the description as well to help yourself with your own questions. Johnny says, so, all right, guys, well, let's go ahead and get started with the questions for this. I'm trying to go for them, but I'm not sure if I did it correctly. Well, I'm not sure. I'll go ahead and take a look at it. I think I got, I don't know, how many did we get to today? Looks like we got to 11 questions actually, and I got 1 open stream. So we got to 10 questions from there. So we'll go ahead and get to those questions. And then I do kind of have a open spot. So therefore, if you have any questions during the stream, feel free, once I get to, question number 5, feel free to open them, add them up. It's always kind of tough to do the, do the open live stream, like during the, or open questions during the live stream, because obviously, don't really know what everybody's asking, if I'm prepared to address your question. And then also like doing the math type sometimes gets difficult, but I always like to answer your questions, or even if it's just like even non-math related, I'm always happy to help that. So get better at math, 3 simple steps. All right, guys, do you remember the 3 simple steps? Get some practice, right? Reflect and challenge yourself. Okay. Definitely go ahead and work on those. Oh yeah, and happy Valentine's Day, everybody. Geez, I kind of totally forgot. Forgot to welcome everybody and happy Valentine's Day. All right, so let's go ahead and get in there, and I'm already on Discord. Well, awesome. Okay, so the first question comes in is find the 5 circular function values of theta given the following conditions. So cosine of theta equals 3/5. Sine of theta is greater than 0. Now, the student did submit like multiple questions to me, and I don't have time to do multiple questions, but I want to kind of like address this one. Even though this is probably one of the more basic questions that they had, but I think it's really important, is when you have conditions on a coordinate plane, right? We have the x and the y-axis, okay? So it's really important that when you understand when sine of theta is greater than 0. Well, sine of theta is greater than 0 in the first and second quadrant. So whenever you're given a condition, identify the quadrants that your condition has to be true, right? So it's going to be true in quadrant 2 as well as in quadrant 1. And that's usually the case, or actually always the case when you're looking at your conditions. Well, it's either going to be in 1 quadrant or in 2 quadrants. Now what we need to do is look at our cosine of theta equals 3/5. Now again, cosine of theta is the adjacent over the hypotenuse. So what we can do is we can create a triangle in this case where the adjacent side is 3 and the hypotenuse is 5. Well, if my triangle has to be in the first and the second quadrant, I know it cannot be in the second quadrant because then the cosine would be negative. So the only triangle that's going to make sense is in the first quadrant. And therefore, we're going to say 3/5. Now, the next thing that's kind of nice about this problem is, and actually I think regarding their other questions, all the rest of them were like Pythagorean triples as well, that using a Pythagorean theorem or understanding the Pythagorean triple, that this other side is going to be 4. So now we can say, all right, well, there's our angle theta. So if we just need to find our trigonometric, how many rates? Find the other 5. Okay, so we have cosine. So we can find secant, which is just a reciprocal. So that's 5/3. We can find, let's see, the sine, which is going to be 4/5. We can do the cosecant, which is the reciprocal of sine. So that's going to be 5/4. And then we can do the tangent of theta. That's opposite over hypotenuse. And then we could do the cotangent of theta, which is, 3/4. And there you go. So yeah, just make sure when you are doing a problem like this where you have a ratio and a triangle to identify your triangle inside of the 4 quadrants, and then go ahead and use your ratio to identify which quadrant your triangle is going to be in. All right, question number 2. It says, in the triangle below, what is the length of the hypotenuse? What is the length of the other leg? So if you recognize this to be a 45, 45, 90 triangle, recognize a 45, 45, 90 triangle is an isosceles, right, triangle. So that means the 2 legs are going to be the same. So that means that's x and that's x. Now, as far as the hypotenuse, you could do the Pythagorean theorem if you want to. X squared plus x squared equals, I don't know, let's call it c squared, or c. Equals c squared. Well, what you get is a 2 x squared equals c squared, square root, c equals x times the square root of 2. So the hypotenuse is x times the square root of 2. So whatever your leg is, all you need to do is multiply by the square root of 2 to get your hypotenuse. And again, that only works for a 45, 45, 90 triangle. All right, question number 3 says, I think the student was asking me to factor. And the student was asking like for some factoring techniques. And I'm not really sure. There was a lot of different factoring problems they sent me. So I just kind of decided to work on this one. And I think we're looking at a problem like this. Like the student was asking for like some factoring techniques, but they gave me like 6 different problems. So if I'm going to give you some ideas in like factoring techniques, I think one of the things that I would recommend doing is like, let's talk about some tricks. Okay, so what are some factoring tricks? Well, I think number 1 is always factoring out the GCF. Like what is in a common term? Like if you can factor out a common term, then factor it out. Okay, now the problem that I'm about to do is actually about to go against that advice. So hold on to that. The next thing would be look for your special product. Okay, and when I'm talking about special products, that means difference of two squares, difference of two cubes, the perfect square trinomials, like look for those kind of techniques. And that's actually what I'm going to do here, because like I could divide by 2 if I wanted to, right? You could divide everything by 2 here. But before I divide by 2, I recognize 64, and that's a square number, right? That's 8 squared. 36, that's a square number. That's 6 squared. That's very, very special, okay? Because if you have a squared term in the front and a squared term in back, you immediately want to look for a special square trinomial. And so to do that, what that's going to be is a binomial squared. So a special square trinomial is going to produce a binomial squared, meaning it's going to be a binomial multiplied by a binomial. Okay. So if that is going to happen, now again, it doesn't always work out this way. So you just want to make sure that your middle term is obviously going to satisfy this. But if this is going to work, it's going to be the same binomial multiplied by itself. All right. So if this is going to work, let's see, we'll have a 64 is 8 squared. So that'd be an 8. And then m to the 4th would be an m squared, right? I'll go through this again. So we have an m squared, because 8m squared times 8m squared is 64m to the 4th, okay? And then our last term here, that needs to be a positive. So that's going to be a 6p, let's see, you're going to multiply those, so you'd be p to the 5th times p to the 5th. So you have p to the, how is that going to work out? I don't see that adding up. P to the 4th times p to the 4th. I do not see that actually working out at all. Because if I was going to add this up, what I would do is I would think of this as minus p to the 5th minus p, or 6p. But this problem doesn't seem like it's factorable from there, right? And that'd be 6p to the 5th. Because if you were to multiply this back out, right, what you do is you would have this one, that'd be a 48 plus 48 is 96. But I'm not sure, these middle terms don't work out. So this would be a 64 m to the 4th, right? And then this would give me a 64p to the 10th, or 36p to the 10th, which is exactly what I was looking for. But as far as my middle term, though, that's not going to really work out. So I'm not sure what I'm missing out on this, but it doesn't seem it's going to be factorable across that unless I'm missing anything from there. But I'm not seeing anybody else's prove me incorrect, or I am using IceBear. I am using Notability app. This is the first time. It's okay, Thomas. It happens all the time. But Thomas, if you can let me know everything, I'm not sure. I don't know. Could be a brain fart, I guess. But to me, it doesn't seem like it's going to be factorable. I just take a picture from somebody's work and it goes a factor, but it doesn't seem like the middle term is going to add to a p to the 3rd power. And I can't factor out a p to the 3rd power. So it doesn't seem like that would work, right? Because if I was going to add these two terms, I would have a negative 96th, and this would give me a m squared p to the 5th power. But that doesn't seem to go ahead and give me an m to the 4th. I'm not sure where that m to the 4th and p cubed would give me, right? Negative 96. Yeah, because if you have if you multiply these terms times these terms, you're going to get a negative 48 and a negative 48, which would give you a negative 96. Yeah, I know it's negative 96. All right. Well, I'm not sure. I went and grabbed the problem, and of course, unfortunately, I deleted where the problem came from. But I think it was as far as looking for something to be factorable. But I'm not seeing this actually to be factorable. So if it was factorable, then we would look at the process that I approached would be fine if it was looking for something like that. But it does not seem to be factorable in this form, right? Or at least across form two binomials as far as I am concerned. So maybe, I guess the only thing we could do is factor out like a number. I guess we could only factor out a 2. Yeah, let's not avoid this challenge. Yeah, seriously. Well, thankfully, this question is not on the challenge, and I have other problems that will be on the challenge that I've already worked through and will have the answers to, so you won't have to worry about problems that will be on the challenge from there. So, but as far as the tricks go, for you guys, those are still going to be the same. Like, I would still look at this and see the 64. I'd still look at this and see the 36. But again, realize that, yeah, the middle term, even though it works out, like the variables are not matching up. So even though the tricks is something I'm immediately like was drawn to, it just didn't match up. So this would not be something anything that would be factorable from there. All right, let's go and take a look at question number 4. So even with the factoring tricks, it's not helping us out. This one says, what's the possible range of values of 8/3 minus 5mx? And this is from Jamal. So the only thing I noticed on this problem, it looks like it was from some kind of like online test or something, is if I divide everything by a 3, then I get 3 is less than a 5mx minus an 8/3 is less than 9. Okay. Now, their example is dealing with a positive 8/3 and a negative 9. So that means they are dividing everything by -1. Well, obviously, if you remember, when you divide by -1, that's going to be flipping the reciprocal, right? So this is going to be a -3 is now going to be greater than a negative or a positive 8/3 mx minus 5. I'm sorry. No, that's not right. 8/3 minus 5 mx, which is going to be greater than a -9. So that has to be greater than a -9, but less than a -3. So those are going to be your range of values. And I'm not sure if this is a multiple choice question or where this question was come from, but I can see that this expression here is basically just my middle term being divided by 3. All right, open question. So whatever questions you guys have for me, it could be on anything that you guys, I see Hayden said, how do you write polynomial functions from complex roots? It makes no sense to me. Well, Hayden, I see your question first, so I'm going to go ahead and answer that. So for instance, if I had like x equals, let's say 2i, and let's say maybe 1, right? Let's go and add it from there. Most you can do is factor out the 2. Hey, thank you. What's your name? Thanks, Maya Motor. Thank you very much for that. Yes, just want to make sure I was not going crazy. Yeah, I could see from the first 2 terms, like you can only factor out the m to the 4th, and these 2 terms you can only factor out p third, or you can factor out a p. So, kind of like it was kind of tricky because it makes you think that you should use a perfect square trinomial, which if you could, it would look like this. But you can't factor out perfect square trinomial, so got a little tricky from there. But thank you so much for confirming all of that. And all right. Oh, wow. Dr. Phil's on. Awesome. Okay, so let's go ahead and take a look at this one. Is writing the equation when giving some complex roots. All right. So we have x equals 2i and 1. So how do we write the equation of the polynomial? Well, the important thing to understand is if you have 2i, then you have to have what we call the complex conjugate, which is -2i. Okay. And so therefore, my factors are going to be x minus 2i times x plus 2i times 1, so that'd be x minus 1. Okay, so these are what we call our zeros. These are going to become your factors. And again, the reason why you have to have the complex conjugate, because again, like just imagine if I have my factor x plus 1, is equal to 0. Well, therefore, x is going to equal plus or minus 1. I'm sorry, plus or minus I, right? So you always are going to include the positive as well as the negative version of I, okay? They always come as conjugate pairs. Always, always. So therefore, if you're given 2i, then you know you're going to be given negative 2i is also a complex 0. If you're given like negative 3i, then positive 3i is also going to be a complex 0. They always come in your conjugate pairs. So the nice thing about multiplying with your conjugate pairs is they're going to produce the, not the Pythagorean theorem, they're going to produce the difference of two squares. So this has become a x squared minus, let's see, the middle term is going to cancel out, or not cancel out, they're going to add to 0, but a negative 2i times positive 2i is going to be a negative 4i squared. I squared is negative 1, so negative 4 times negative 1 is going to be a positive 4 times the x minus 1. All right, and then from here we can just use the, again, FOIL one more time. All right, so x squared times x is an x cubed. I don't know why I put parentheses again. Come on. All right, so this is going to be a x cubed minus x squared plus a 4x minus 4. And there you go. Now, this one actually came up that actually works very, very similar to what we were just talking about. It says, we know we have graphs that have curves that fall down, rise up, depending on the exponents, right? For example, x to the 7th has 6 curves to the right. So that's a potential, or up to 6 curves, or 6 turning points. So whatever the degree is, you have a possible maximum number of 1 less than the degree, which is 6 curves. So their question is kind of related to that. It's like, why is it up to, right? Why in some cases, if the exponent is x to the 7th, then the graph may only have 6, 4, or 2 curves. Why does the number reduce even if it is x to the 7th? So very, very good question. And to answer that is what we call multiplicity, which we call repeated, I don't know why I did that, repeated zeros. Okay, so if you're just to graph y equals x to the 7th, just graph that. Just go ahead and graph that. If you go and graph that, it's going to look something like this, which is very similar to y equals x cubed, which is like our standard S curve, right? So you're like, because again, like if you think about that, like when is this graph equal to 0? Well, it's equal to 0 when y is equal to 0, right? Or when x, like, that's it. There's no other zeros there. So there's going to be no other turning points or no other curves, okay? So the reason why this works is because, again, yes, the fundamental theorem of algebra says you have to have 7 zeros, and that is still going to be the case, okay? But the zeros are just repeated. So it's, x is equal to 0 7 times. And when you have multiplicity, that's what happened. That's why we only say it doesn't have to have 6 curves when you have x to the 7th. It can have up to 6 curves as x to the 7th. So the difference is going to be multiplicity. And just to kind of give you like one more example, y equals, well, I don't know. I'm not sure if that's really going to help out your understanding at all. But yeah, let's just stick with the multiplicity. I think that's the easiest and best description. I was going to kind of go a little bit deeper into this, but you could have like x to the 7th, anything else you're going to add into it. It's just going to add in additional zeros to it, additional turning points. But if you have that, when you have x minus c raised to the m equals the multiplicity. And again, all we need to make sure we have, I don't know why it's giving me such a big deal. All we need to make sure we have is the power of our factors is equal to our degree of our polynomial, and that is to include the multiplicity or the repeated zeros of our polynomial. Okay, question number 7 says, I think we're just supposed to subtract. I think I remember the student was asking something else from this, but I don't remember. So in this example, the first thing we're going to want to do is simplify, right? So before you go and like apply your operations or subtract, like just simplify. Simplify, simplify. So in this case, we can see we can factor out 2. So by factoring out 2, I'm going to be left with an x squared plus x minus 6. And they say, okay, how could I maybe simplify that? Well, you say, oh, okay, that's going to be ax. Let's see, that would be plus 3 times x minus 2. Right? And then this, we can factor 2ax plus 2 times ax minus 2. All right. So now what we need to do is identify, well, what is going to be my common denominator or my LCD? LCD is probably actually better because you don't want to find the common denominator. You want to find the LCD. So my LCD in this case is going to be a 2, x plus 3, x minus 2, times x plus 2. Because again, my goal is to combine them, right? To get the common denominator. So I already have an x plus 2, x minus 2. All I need to do is multiply this by a x plus 3 over a 2. And again, I need to do that on the bottom, as well as the right side. So x, come on. Well, I guess I write 2 times x plus 3. Okay, on the left-hand side, I already have the x plus 3, and I already have the x minus 2. All I need to multiply here is by the 2. No, I already have the 2, but by the x, plus 2. And I got to do that on the top as well as the bottom. Okay, so make sure you do distributive property. Make sure you recognize that, though, to be a -2, right? So a lot of times it's helpful to rewrite this as a positive to a negative. All right, so let's see what we got here. So we have a 6x plus 12, and this is going to be a plus. A -2 times 2 is a -4. So this is going to become a -4x, and then a -4 times 3 is going to be a -12. This is going to be all over my common factors of x plus 2 times x minus 2 times x plus 3 times equality 2. All right, and let's just go ahead and simplify this one more time. Combine our like terms. -4 times 6x is going to be a 2x. 12 minus 12 is going to be 0. And then over here, let's just rewrite this as factor terms. And there you go. All right, question number 8 says, given f equals 1 over 4 pi e divided by q1, q2 divided by r squared, make r the subject of the formula. Basically, in my opinion, would be to solve for r. All right, so we have r squared in the denominator. We cannot solve for r in the denominator. We want to get r out of the denominator. So to do that, what we need to do is understand, well, what is being, like, to do that, before we can understand, like, getting r outside the denominator, let me just go and rewrite this. Okay, so what I would do in this case is I would go ahead and multiply by an r squared on both sides. Now, what is that going to do? Well, since these are separated by multiplication, you only need to multiply, like, you don't need to apply distributive property. It's just the whole quantity is being multiplied by r squared. So the cool thing about that is that's just going to divide out over here. So then I'll be left with an f r squared equals 1 over 4 pi e times q1 times q2, right? Which you could just put into the numerator over here. Now, rather than multiply by or dividing by r squared, I can just multiply by the reciprocal, which is 1 over r squared. So therefore, I can finally get my, not r squared. I want to divide by f, right? I want to solve for r. So I'm going to multiply by 1 over f, which is the same thing as dividing by f. So therefore, I get an r squared equals, let's put these in the numerator. So that's q1 over q2 divided by 4 pi e f, right? Because you can multiply those. And then now I can just take the square root of both sides. So r equals, we can say plus or minus q1, q2 divided by 4 pi e f. There you go. All right. Let's see what you guys' questions come back to. Oh, wow, you guys are in. Question number 9 says, write the equation of the line with the slope negative 3 pi over 2 with a y-intercept of 0, comma, negative 2. So you can write the slope in, or you can write the equation of the line in point slope form, in slope intercept form, in standard form. If I was writing in a point slope form, it'd be fairly easy. So I'm assuming the student would maybe like me to write it in slope intercept form. I'm not, well, even slope intercept form, I'm not really sure. So if I had y equals mx plus b, remember m represents the slope and b represents the y-intercept, right, which is your coordinate point. So in this equation, I'm just going to write negative 3/2 x plus, that's a b, which is negative 2. So y equals negative 3/2 x minus 2. Okay, so the y-intercept where the graph crosses the y-axis, so b is equal to negative 2. And slope is going to be, obviously, m. There you go. All right. Question number 10 says, solve the simultaneous equations y equals 4 minus x, and then, oh, I didn't even look at this. It was a y squared. I didn't look at that. All right, well, I don't, is that x squared or 2x? I guess it's, I'm assuming it's 2x. So I'm not sure if I copied down this equation correctly. So typically whenever you have a y solved, all you're simply going to do is just plug that in for y into the other equation. So I'm assuming this is 2x equals, I'm sorry, not equals. 2x plus a 2 times what is y equal to, right? So if we have y squared, like y is equal to a 4 minus x, right? So that's going to be squared equals 67. So now we're going to have a quadratic equation. So let's just go and see if we can work out. I'm not sure if this is going to, see if my graphing calculator still has power. It does, very low, but let's see what happens. Okay. So I have a 2x plus 2. Let's see, this is giving me a 16. This will give me a minus 8x plus a x squared equals 67. Okay, and then we'll apply a distributive property here. So 2x plus 32 minus 16x plus 2x equals 67. And then we'll just go ahead and get everything to the same side. All right, so I finally end up with a 2x squared. A 2x squared. Let's see, this is going to be a minus 14x. And then 32 minus 67, that's going to be a 35, negative 35. Okay, and then from there, you're just going to want to solve the equation. And once you go ahead and solve for x, then you can go and solve for x into y. But I'm not really sure if that's going to be factorable. You could, no, you can't factor out 2. 7 times 5. Well, let's go into 35. Let's go and see if this is. So 2x, x, right? So we need to equal to 35. Let's see if this is factorable. So it'd be 7 times 5, but that's 7. That'd be 14. No, I don't really like that. I'm not seeing that's going to factorial. And without actually using my calculator or graphing technology, we could either look into more factoring techniques or just look into using the quadratic formula or looking at graphing technique to solve. But as long as I did my math here, he is saying x squared. Yes. So as long as I did the math up to this point, you're going to want to solve for x. And just not to keep this stream going too long, you're going to want to solve for x here by either factoring, quadratic formula, or graphing. And then whatever x equals, you're going to take that value and you're going to plug it in for y. And that's basically how you'd solve those simultaneous equations. All right, but it doesn't look like it's going to be nice. So that's why I'm just going to move on from there, and you can just, find those values and plug them in. All right, number 11 says, draw the triangle PQR, 1, 2, Q, 3, 5, and R. So I think it's important when you're given coordinate points to plot them. Like I tell my geometry students this all the time, like, hey, it's okay if you don't know what you're doing, but if you're given a coordinate point, plot the points, 1, 2, 3, 1, 2, 3, 4, 5. Just plot the points. And then 6, 2, 1, 2, 3, 4, 5, 6. You had a lot of teachers that worked really hard to help you learn how to plot points. So plot the points. So you recognize this is a triangle. Okay, good. So it says find the image of PQR under the following rotations. So 9 degrees anti-clockwise. So yes, that's going to be clockwise around the center of 0, 0. Okay. So we got to understand what's happening when we rotate something counterclockwise. All right. So what I want you to do is think about a coordinate point, 1, 2, 3. And I always like to use the point 3, 2. If I was about to take this point and I was to rotate it counterclockwise, well then it's going to look like this. It's going to be a negative 2, 3. So if this point was 3, 2, when I take this, take everything, take the x-axis, the y-axis, and the point. If you were to rotate that to the left, right, which would be counterclockwise, 90 degrees, you would get this point, which is a negative 2, 3. So what I want you to recognize is if this is my x and my y, then my new rotated point is going to be a negative y, comma x. So that's all we need to do for these points. All these points are going to have the exact same thing. We just need to flip them and negate the x. So P prime, which we're going to call our image, is going to be a negative 2, 1. Q prime is going to be a 5. Sorry, negate it. Is going to be a negative 5, 3. And then R prime is going to be a negative 2, 6. So let's go and graph it and just make sure that it makes sense, okay? So let's do negative 2, 1. So that's going to be P prime. Let's do Q prime, which is negative 5, 3. So 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3. It's going to be Q prime. And then we'll do R prime, which is negative 2, 6. 1, 2, 3, 4, 5, 6. Okay. And then again, does this look like that triangle rotated 9 degrees? No, I'd say, yeah, it does. All right, cool, ladies and gentlemen. That is it. So hopefully I was able to answer majority of your questions and help you guys kind of out. If you guys maybe have a bonus question or two, I might be able to get to it. We'll just kind of see. But thank you so much for staying on for this live stream and covering some of those 3 tips, which let's go ahead and cover one more time because I do feel it is very important for us to kind of remember the purpose of the stream. And obviously I always love answering your questions. That's why I've been doing live streams for so many weeks in a row. But I think one of the important things is for you guys to remember, it's like, hey, I think a lot of people show up to live streams or on my channel because they're like, I want to improve my math skills. What are some things I need to do? And I know everybody would love to have some tricks, something easy that they don't have to work at it. But the truth is, question number 1, tip number 1, you got to put in the practice. You got to put in the work. You got to put in the effort. If you're going to get good at any skill, you got to put in the work. And I think it's very important to make sure that you're doing the work correctly. So make sure when you're putting that work that you know the answers, that you know the correct solution and steps, and work from there and keep on repeating that. One thing that I didn't mention up to now is one thing I used to do is I used to go through my problems in my notes. I'd cover them up and I'd work through them over and over. I already knew what the answer is. I already knew how to do it, but I'd work through them over and over just to kind of build those foundational skills because, I used to be weak at math. So I had to kind of build up that practice. You do multiple problems over and over again. And number two is going to be reflect on your learning. Like, reflect why you're learning these things, what you're learning, how does it reflect, how does it connect to what you already know? And then also when you get problems wrong, like reflect on why you got them wrong. So, one of the things I like to do is every, kind of test that I have, I like to create like a cheat sheet to kind of make the connections, to write down the things that I understand about a certain concept or chapter, and then just try to like reflect on that. Like, how does that connect to what we've already learned in this course? Because we're kind of getting to this point. For a majority of you, already been in class for a while, and there's already been a lot of stuff that's been kind of like thrown at you. Like, how does everything connect? Like, what are some things that you maybe were taught at the beginning of the year that you didn't really understand, or really kind of see like, why is this important? Why am I learning this? Like, how does that connect to what you're learning now? What are some similarities? And then also, like, when you get something wrong, just don't throw it away in the trash can or just be like, I just made a mistake. Like, really try to understand your mindset and what you were thinking when you were working through those problems. I think it's really, really important for you to understand when you get questions wrong, because, when I was taking tests and I knew what kind of test taker I was able to realize, when I was going to make mistakes and how I was going to make mistakes, and I could help prevent myself. And again, I still make a ton of mistakes. I still get lazy, and I'll still make the same mistakes that I know I'm going to make. But I think it's really, really helpful and important when you can anticipate the types of problems that you're going to struggle on, and to really understand that, what type of, kind of learner you are, and and also the type of math student you are, that you can not only like improve your skills, but also kind of know like when you're going to make mistakes. And it's kind of one of those weird weird kind of like skills, I'd say, is kind of important. And the last but not least is to challenge yourself. And that's one thing that I want to help you guys out with, which again is going to come up with in next week. I'll let you guys know, where I will have a opportunity for you guys to get consistency with your problems. Also to be able to reflect on the problems you're doing, and then also hopefully to go ahead and challenge yourself. But that is going to be coming up for next week, so I will hold those details for you guys then. All right, just been practicing for 2 or 3 months, no improvement, panicking when taking the prize. Yeah, it's I'm not going to say just because you're doing math questions, over and over, that it's like an automatic, guide to success. It takes a while, and the hard thing about math too is like, not everybody's on the same time frame. You can't compare yourself like, hey, I've been doing problems, for a month, and then like, the person sitting next to me and my best friend has been doing it for a week and they already understand it. Like, that's not fair to you, and it's not fair to them. So, don't hold yourself in comparison against anybody else. You got to do the best you can do for yourself and keep on working at it and put in the time, the effort, and that's all you can compare yourself against. I'm currently in the 12th grade. Another question. I have 10 math classes. I have to finish each in 2 weeks. Man, what? How? I don't understand. You're in 12th grade. You have 10 math classes. I don't even understand that. I'm assuming maybe like 10 video classes, and I would just say try to get them done as soon as possible. I'm not really sure what else I can probably say. I would say, I'm assuming these are like 10 individual classes that you have to do. And if you have 2 weeks, that's in 14 days, I would say try to double them up. Like, double them up. I'm assuming you have like some kind of test. So what I would say is do those, get them done within 5 days, and then spend the next 5 days reviewing what you just did, doing the work, whatever work you need to get done, and preparing for the test. Like, because yeah, that's no joke. The last thing you want to be doing is doing a class before you have to take a test or before the end of the year. Like, get that done ASAP. You want to spend the last week that you're in this class or whatever you're doing, like reviewing and studying and relaxing. So do whatever you do, make whatever sacrifices you need to make, but I would say get those 10 classes done ASAP. Well, hey, Pablo, good to see you. Is algebra an important class? I'm trying to skip it, but I'm not sure if it's too important for the SAT and ACT. I would say that majority from what I have seen, I'm not really a big ACT, SAT kind of person. So I'd probably rely on some other resources for that. But I would definitely say for the ACT and SAT that if you have a strong Algebra 2 background, that's going to be pretty important. And as far as what I have seen on the SAT and ACT, like as far as like, you know, some review problems and packets, I would say it's like heavy Algebra 1 or Algebra 2 content. So I would say if you feel comfortable with the Algebra 2 content, then yeah, you can maybe like go ahead, like skip it for whatever reason you're trying to do that. But if you're having those questions where you even have to ask me, should I skip it? You might want to make sure you just do the content to have a strong background, from there. Where for you to find discover your channel, we always say if you confuse, watch the bald man. He's the best. Well, thank you, I swear. I appreciate that. Yeah, good. Thank you, Hayden. So yeah, that's good to know. Algebra 2 is basically everything on the SAT, which I would probably confirm. I'm not a big Algebra 2 person, so that's not something I would want to confirm, but I would probably say that's probably a good way to start. For the x-intercept y, do you always set the equation equals 0, or do you just plug in 0 for x and plug in 0 for y? So, Susie, the x-intercept, let's not memorize this. If this is the y-axis, this is the x-axis. So if you're looking for when a graph is crossing the x-axis, right? Y is equal to 0, right? So the x-intercept, y is equal to 0, right? That means whatever the equation is, you're going to plug 0 in for y and solve for x, right? So plug 0 in for y and solve for x. Now again, what about here? What about the y-axis? Well, that's when x is equal to 0, right? So the y-intercept, x is equal to 0, meaning plug 0 in for x and solve for y. Okay, so hopefully that kind of helps. I don't want you to memorize this. I want you to visualize this graph from now on. And because no matter what happens in your mathematical career, no matter how difficult the problems get, you can always rely on those two rules. What level of math are you teaching right now? I'm teaching multiple levels. I'm teaching geometry. I'm teaching Algebra 2 honors and pre-calculus. So I'm teaching three classes this year. I'm in 10th grade taking Algebra 2. Well, awesome, Hayden. My friends, yeah, I would definitely say, as far as what I've heard from my students, SAT, it kind of feels like Algebra 2. Logic and it covers. So Austin's saying, can you tell me what topics are in symbolic logic and if it covers some topics from discrete mathematics as well? I'm not sure how to answer your question. If it covers some topics from discrete mathematics as well. But I would say logic is definitely typically in a discrete mathematics course. But maybe if you can maybe restate that, Austin, I can maybe address that a little bit better. Sorry, I'm not really sure if I understand fully. So if you're describing the key features of the polynomial and the x is the fifth power, is the degree 5? Well, yes, assuming the degree is assuming 5 is the highest power, then yes. Whatever the highest power is, that's the degree. I'm in Canada right now. I'm moving to the U.S. and I want to enter a university. What do you think I should be summarizing for the SAT test? I guess people are kind of giving away that SAT is very Algebra 2-ish. To be honest with you, I think if you just kind of look at some SAT prep booklets, I'm not affiliated with any of them, so I'm not going to give a plug. But I think if you just kind of do anything that's a SAT prep, I think you'll be okay. And I think if you just kind of do things like I'm outlined in this live stream, put in the work, reflect when you get them wrong, try to do the challenging problems. Just don't do the problems you know how to do. I think if you do those 3 things, you'll be perfectly fine for the SAT. Well, thank you, Sandra. I appreciate that. And thank you, Anthony. Appreciate that. Will you cover set theory in the future? I actually have some very, very older videos on set theory. But I haven't covered more set theory. But one of the things that I am actually more interested in is actually doing more discrete mathematics and doing more set theory and graph theory. Those are things that I actually really like doing. I know it's not something as common that a lot of students are taking, but as far as like teaching and learning and understanding it from a student perspective and teacher perspective, that's something I really enjoy. So that's something I'm looking forward to coming up on my channel, just probably not something that's going to be initial since I'm still teaching inside the classroom, at least for this year. I'm not going to be able to do that. All right, can you please show me, 4 equals square root to f plus 4 minus 36. 17 equals 4. I'm not sure. Okay. Yeah, Jays, I'm not going to be able to cover your questions. If you want to go ahead and submit that for next live stream, though, in the description below, you can do that. I'm actually past my 2-minute live stream mark, but if you want to go ahead and submit that for the next one, that'll be awesome, and I'll be more than happy to kind of work through that problem. Or any other questions you guys have. Yes, thank you, Addie, for the plug on my website. And also, I have, you guys can also go ahead and submit your questions in the description down below, as well as if you guys have more questions after this live stream, please go ahead and take a look at the Discord server, which is in the description below. You guys can go ahead and join, submit some questions, post some questions, answer some questions, help some students out. I am really looking forward to growing this community on Discord. And just having something where, everybody feels that they can have a place to get their answered questions and help each other out. I think it's really an awesome thing. All right. So, is AP Stats worth it? I would say yes, Hayden. I'm not going to do any more math problems, though. My brain is kind of fried from tonight. It's been a nice weekend. Awesome. Jenny, that's sweet. The stream isn't pre-recorded. No, Will. I am on live. He's answering questions. Yeah, I answer some questions live, but once I go past the hour mark, I kind of just don't take any more questions just because my brain kind of a little fried, and it's a little bit nice. Typically, I have to get ready for school tomorrow, but the cool thing is I don't have school tomorrow. So we have President's Day here in the United States, and in my school, or my district, we have that off. So that's why it's been a little bit nice not having to worry about that. Preco's my bad one. But yes, thank you so much, Addie. All right, guys, I am going to sign off. Blue Line, I see your question. Please go ahead and submit it in the description below. And again, guys, if you have more questions, put them in the description or go ahead and take a look at the link in the description below, or go ahead and head over to Discord. I am on there from time to time answering questions or helping you guys out. So feel free to go ahead and jump on the server, post some questions, help each other out. And I will see you guys next week. And remember, I'll have the challenge details up and ready for you guys. All right, guys, I will see you then. Have a great night as well as week. Cheers.